couple of things. I will post these notes and the recordings both from Wednesday and today up on Canvas this afternoon. Just a note about the final. The last page of the final will be optional extra credit. It's multiple choice. You do not have to show your work. And I've already posted the problems. So if you go into Canvas today or sometime over the weekend, you can do the extra credit ahead of time, even though the final exam won't release until Tuesday. So just wanted to let everybody know about that. And with that, let's keep going through last year's final. So, and you can stop me at any time. And if there are any other problems y'all want to take a look at, you can stop me, put things in the chat. But this is problem 10. And the instructions are my usual favorite instructions: simplify. There are lots of different ways to approach this, but I'm really just going to use our exponent rules that we were reviewing at the end of class on Wednesday. So everything inside of my parentheses is multiplication. I don't have any addition or subtraction. So I don't have to think about kind of foiling things out. Instead, I can just think about making sure that this exponent belongs to each piece inside. So I'm going to write out an extra step that you don't need to write, but that you do need to think through. This means that I have 3 cubed and x cubed cubed and y squared cubed. This next piece says that I have 4 squared, x squared squared, and y squared. And that last piece, I've got 3 cubed and x squared cubed. And the number one thing that I would say to be careful about, that I saw a lot of mistakes during the quarter on, is to make sure that you treat those numbers the same way you're treating the variables, meaning those numbers are raised to exponents also. 3 cubed, that's 27. Cubed, cubed, powers raised to powers, I'm going to multiply those. So that's x to the 9th, y to the 6th. 4 squared is 16. X squared squared, I'm going to have x to the 4th, y squared. 3 cubed again, I've got another 27. And x squared cubed is going to be x to the 6th. Now, when I go to combine things further to simplify, I'm going to kind of group my numbers together. And I'm going to group my variables together. Everything is multiplication at this point. And when I multiply 2 things with the same base, I'm going to add those exponents. So I'm going to have x to the 9 plus 4 plus 6 and y to the 6 plus 2. So I've got 27 times 27 times 16, x to the 19th, y to the 8th. I don't particularly care if you multiply this out. Do not waste your time multiplying it out without a calculator. The numbers are just too big. As an alternative to multiplying it out, it would be completely acceptable for you to treat the numbers the same way we did the variables and to just write that as a base raised to an exponent. Meaning this could look like 3 to the 6th times 4 squared times x to the 19th times y to the 8th. So there's a question in the chat about the extra credit. The extra credit is already posted in Canvas. So if you click on that final exam, I haven't released the questions for the final for this fall, but I did release the extra credit page. So you can go ahead and figure those out ahead of time. Like anytime between now and Tuesday at 3 p.m. when you need to turn in the final. So I'm just giving you extra time to do the extra credit. The instructions are on the page, but it's multiple choice. You do not have to show your work. Okay. Question? Oh, simplify. Instructions for number 11 are to multiply. And I'm looking at the square root of x plus 3 squared. So this is super recent stuff. This is like quiz 9 stuff. And I have to say, y'all did really good with these kinds of problems on quiz 9. So hopefully it's fresh in your memory. One thing to just remember, when we have something like in parentheses that's squared, if I've got addition or subtraction inside, I really want to think about that as that whole thing in parentheses times the whole thing all over again. To make sure that we're foiling this out correctly. So if I start with that square root of x, when I multiply the square root of x times the square root of x, I get x. The square root of x times 3 give me 3 square root x. I have another 3 square root x. And finally, I have a positive 3 times a positive 3 to give me a positive 9. It's okay to leave it like this, but if you can, it's usually a good idea to at least combine like terms, which would make this look like x plus 6 square root x plus 9. Problem 12 is a word problem. And it says that the length of a rectangle is 6 more than twice the width. Write an expression for the perimeter. Now I want to point out a couple of things here. So first of all, what we're being asked to do is write an expression. There's nothing that we're solving for in this problem. We're just being asked to write an expression. Now, the next thing is, what are we being asked to write an expression for? The perimeter. So I'm going to start by writing perimeter equals and think about generally for a rectangle, if I've got a width and a length, then my perimeter would be twice the width plus twice the length. But we know more information in this problem because we know that the length is 6 more than twice the width. So if I take that first sentence and convert it to mathiness, the length is, so that means length equals 6 more than, so 6 plus twice the width, twice the width. So my expression, my final expression for the perimeter would look like twice the width plus 2 times 6 plus twice the width. By plugging in all of that for the length. Y'all can slow me down with questions anytime. But if not, I'm just going to keep cranking through this. So question 13. The instructions are just divide. Now what we've been given is 6a cubed plus 18a squared plus 12a plus 6 over 3a. Now we have two options here. So one option is to think about this with polynomial long division and write the entire top on the inside and the 3a on the outside. But we kind of have another option because we only have a monomial on the bottom. I don't have any addition or subtraction in what's on the bottom. So one option is to think about this as 4 separate fractions, each with a denominator of 3a, and to simplify each piece. So I'd have 6a cubed over 3a plus 18a squared over 3a plus 12a over 3a plus 6 over 3a. And then in each of those, I'd be thinking, can I find a 1 that I'm multiplying by? So if I look at this first one, you do not have to show this extra step. I'm just doing it to kind of illustrate what I'm doing. So I can think about that 6a cubed as saying 2a squared times 3a. Now, why am I doing that? Because I have a 3a on the bottom. This next piece, I can think about that 16a squared as 6a times 3a. Again, I'm doing that because of that 3a on the bottom. That 12a is 4 times 3a. Oh, it's an a. It's an a. And that 6 over 3a, I can write as like 2 times 3 over 3a. So my 3's will cancel out, but not the 2 or the a in the bottom. So if I kind of recollect that back together, that turns into 2a squared plus 6a plus 4 plus 2 over a. And that's really where I would leave it. I'm going to need to flip the page for the next one. So I just want to make sure that I'm giving everybody time to catch up in your notes if you want. So problem 14 asks us to factor completely. So the first thing that I want to look for is anything that our three pieces have in common, right? So that I can pull out that greatest common factor. Looking at all three of those, I know for sure I can pull a 5 out. And they all have some number of X's and some number of Y's. So I know I'm going to be able to pull something out there too. So if I look first at the X's, I've got an X to the 4th, an X squared, and an X. So X is the only thing I can pull out. If I look at the Y's, I've got a Y squared, and a Y cubed. So I can pull out a Y squared. If I factor all of that out of my first piece, what I'm going to be left with is X cubed. And remember, this whole idea of like pulling something out is that if I were to distribute this back in, I should come back to what we started with. 5xy squared. If I pull all of that out of here, I'm going to be left with a 2 in terms of the numbers. I'm going to be left with an X, but all of my Y's have been pulled out. And from my last term, I'm going to be left with a 5. My X has been pulled out. And a Y squared has been pulled out, meaning I'm left with Y. And that's really it. I'm just going to write it a little bit neater, but that's the best we can do. Taking a look at number 15. Number 15 asks us to solve for X. I have fractions, but I've also got an equal sign. So we have a choice. We can either get a common denominator, or my preference, because we have an equal sign, multiply both sides by that common denominator to get rid of the fractions entirely. So I'm going to come in here and multiply both sides by X minus 4 and also by 3. On the right-hand side, that means that my X minus 4 over X minus 4, that's my 1. I'm just left with the 4 times 3, or 12. On the left-hand side, when I distribute it in, I just want to be careful. So when I distribute this into the first piece, the X minus 4 and X minus 4 will cancel out, leaving me with 3 times 2. When I distribute to the second piece, the 3's will cancel out, leaving me with an X minus 4 on the top. Now, some of you have been making some mistakes on problems like this on the quizzes. And I think it kind of comes down to keeping track of what's in the numerator and what's in the denominator. So in case it helps, I could be more explicit about that in this problem. And I'll do that in a second, but let's just go ahead and solve it really quick, and then I'll go back and do that. So 3 times 2, that's 6. And when I distribute this minus sign, I'll have minus X minus a minus. I'll make that plus 4 is equal to 12. So 10 minus X is equal to 12. which makes negative x equal to 2, or x is equal to negative 2. So if I were to go back and kind of do this, but be more explicit about my numerators and denominators, I had 2 over x minus 4 minus 1/3, and I'm going to give myself like a ton of space here, is equal to 4 over x minus 4. So when I go in to multiply by that common denominator of 3 and x minus 4, I'm going to go ahead and write that in next to each term. So I'm multiplying by x minus 4 over 1 and by 3 over 1. And I'm doing that on each term. I don't usually write the over ones, but I would encourage you to do so if you've been having any trouble keeping track of what's in the numerator and what's in the denominator on these problems. So now I think it's a little bit easier to see that x minus 4 over x minus 4 is a 1, and the 3 over 3 is a 1, and the x minus 4 over x minus 4 is a 1. And now all of my denominators are 1, so I don't have to write them. I'm back to 3 times 2 minus x minus 4 is equal to 4 times 3. We should get exactly the same answer. So question 16 says, it takes me 15 minutes to walk 1 mile. How many miles can I walk in 1 hour? It is totally fine if you just logic your way through this in your head. And it's also totally fine if you need to write some math. So the thing that I'm trying to figure out is how many miles I can walk. So I know that my final answer has to be something with units of miles. So we can treat this as kind of like a unit conversion thing. So the only ratio that I have here that includes miles is 15 minutes in 1 mile. Because I want miles to be my final answer, I'm going to put that ratio with miles on top. So 1 mile per 15 minutes. Now I know I'm going to have to get rid of the 15 minutes, so I've got to multiply by something that's in terms of minutes. But unfortunately, I didn't give this to you in minutes. I gave it to you in as 1 hour. So you can either write an additional conversion and say there are 60 minutes in 1 hour, and then multiply by 1 hour. So my hours cancel out, my minutes cancel out, And my final answer, right, I'd have 60 over 15 miles. But we know we can reduce that fraction. So if you don't see it like all at once, you can always break it down a little bit at first. And I would say, I know that 60 is 3 times 20 or 2 times 30. I feel like 2 times 30 would have been more helpful, but I already started writing this, so I'm just going to go for it. Is 3 times 20. But 20 is 2 times 10. And 10 is 2 times 5. And that would be my prime factors of 60. And 15 is 3 times 5. So that means that my 3 over 3 becomes a 1 and my 5 over 5 becomes a 1. My final answer is 2 times 2 or 4 miles. And if you know that 60 divided by 15 is 4, you don't have to write any of that out. You can just write 4 miles. That's totally fine. Problem 17 asks us to solve the system. Oops. This system using any method. And then graph to verify the solution. So I've got x minus y is equal to 3. X plus 2y is equal to 0. So just as a refresher from, I think chapter 3. No, I don't know. I don't remember what chapter. Sorry. I could go look it up. So could you. We've got 3 options for solving a linear system. Graphing them is generally not the best choice unless you have some sort of graphing tool that you're using. I would say if we're going to work through the algebra, we've got elimination or substitution as options. I would probably go with elimination on this, but substitution is also fine. If I went for elimination, I'm trying to eliminate either the x or the y. So the first thing that comes to mind to me would be to make the y's go away by multiplying the top equation by 2. And if I did that, I'd have 2x plus x, I get 3x. I'd have negative 2y plus 2y, so I'd have 0y. 2 times 3 is 6, 6 plus 0 is still 6. So 3x is equal to 6 or x is equal to 2. Then I can plug that into either of the other 2 equations to get the y value. I'm going to choose the top. So 2 minus y is equal to 3. Negative y is equal to 1. Y is equal to negative 1. So my solution as an ordered pair would be 2 comma negative 1. Now the graphing it to verify the solution. The solution should be the place where there's 2 lines intersect. So if I look at the top line, the x minus y is equal to 3. My guess is that most of us kind of think a little bit better for graphing lines if it says y equals. So I'm going to go ahead and rearrange that. I would add y to both sides and subtract 3 from both sides and get x minus 3 is equal to y. So this has a y-intercept of -3 and a slope of +1. That other line, the x plus 2y is equal to 0. If I get y by itself here, I've got 2y is equal to -x, or y is equal to -1/2 x. This has a y-intercept of 0 and a slope of -1/2. So a slope of like down 1 over 2. And then I'd go, yep, that looks like 2, -1. That's our intersection point. Pausing for a second because there was a lot going on in that problem, just to see if anybody's got questions. Yeah. So solving the system, the solution to the system is 2, -1. Neither of those are a y-intercept. But to show the graph, what I need to show is that they intersect at 2, -1. You don't have to use the y-intercept to graph them. You just need any 2 points. I used the y-intercept to graph. I don't know if that answered your question. Okay. So this is really 2 questions for the price of 1. If all it said was solve the system using any method, that's what I would have done. But solving the system means you have to give both an x value and a y value for the solution. Because I said to graph it, now we have to somehow graph these equations. And for me, it's easiest to graph it by finding the y-intercept and the slope. So looking at question 18. I am going to make a comment about quiz 9. On quiz 9, I specified for some of the questions which method you had used to solve them. And if you used a different method than what I specified, you got 0 points. So some of you are going to have very low scores on quiz 9, not because you didn't have mathematically correct answers, but because you didn't read the instructions and follow the instructions. So I just want to give everybody a heads up on that. Same thing is going to happen on the final. If it says you need to solve it by completing the square, if you factor it or use quadratic formula, I won't give you points on that problem. It's important because we have to use all 3 of those methods in calculus. I need to test you on all 3 of those methods. So if it says that you have to use a specific method, that's what you need to use on that problem. Okay, so if we're going to solve this by completing the square, I can either get that 3 out of the way by writing it on the right-hand side or just giving myself a little bit of space. So I've got x squared minus 4x, leaving space to add something and subtract it back off. So I'm going to take half of -4, which would be -2. So I'm going to have x minus 2 squared. -2, when I square it, I'm going to add it in and then subtract it back off. -2 squared is +4. So this is going to leave me with x minus 2 whole thing squared minus 4 minus 3 is equal to 0. So to solve this, I'd have x minus 2 squared. That would combine to be a -7, and I'll add that to both sides so that I've got equal to +7. When I take the square root of both sides here, I'll get positive or negative square root of 7. So my final x values would be 2 plus the square root of 7 and 2 minus the square root of 7. Yeah.
Say if we don't put the plus
Mhm.
square root, would we be getting the points deducted?
Yeah, because it has 2 solutions, right? I would say, like, if you didn't write them on this step, but then you wrote it out in your solution as 2 plus 7 or 2 minus square root of 7, like, I'd give you full points for this part, even if you left it off over here. Yeah, but there do need to be the 2 solutions. So on this, on last year's final, questions 19 and 20 were both quadratic, but I said you can solve them any way you want. So question 19 just said to solve, and it says you may factor, complete the square, or use quadratic formula. Now I will say not everything factors, so sometimes you don't get that as a choice. Does anyone have a preference of what I do to solve this? Sure, let's use quadratic formula. So our quadratic formula looks like x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2a. If you use quadratic formula on the test, I do not expect you to simplify it unless the number inside the square root is a perfect square. But I do want you to get the part under the square root to be a single number. But after you do that, you can stop. So b here is 2. So I'm going to end up with -2 plus or minus the square root. 2 squared is 4 minus 4 times 5 times -24. All divided by 2 times 5. You don't get to quit yet because you do need to deal with what is under the square root. So I'm going to kind of come off to the side and deal with the numbers for a second. 4 times 5 is 20. So I'm really just gonna think about this as 4 plus 20 times 24. And I can do this as 2 times 24 to get 48 and then append a 0. So this would be like 4 plus 480. So I'd have -2 plus or minus the square root of 484, all divided by 10, and it's totally fine if you want to leave it just like that. Oh, yeah, if you want to try to simplify what's under the square root, you can definitely do that as well. Yeah, so as soon as you've got all the stuff under the square root as a single number, I'm fine. You can walk away. If you want to simplify it more, you can, but if you simplify it incorrectly, you'll lose points. And if you just stop there, you know you're right. And problem 20, last one on the final here. It's another quadratic and we can solve it any way we like. X squared plus 7x minus 10 is equal to 0. And I would probably go for quadratic formula here. I don't think that factors. Because to get a -10, I need one number to be positive and the other to be negative. So like 5 and 2 would add up to 7, but I would need one of those to be negative. So it's not really going to work. So I think we're going to have to quadratic formula it. By the way, this one does factor, pretty sure. But I'm going with x is equal to -7 plus or minus the square root of 49 minus 4 times 1 times -10. All over 2 times 1. And we get to quit as soon as we get the stuff under the radical to a single number. This one I can do in my head. 4 times 10 is 40. A negative and a negative makes that positive. So this will be the square root of 89. All over 2. And I don't even think there's something you could do to simplify that even if you wanted to. I think that's it. We got 5 minutes left. Just a couple more quick announcements / reminders. And I will put all of this in an announcement in Canvas as well. Okay, someone just asked a question I was going to talk about, the math placement exam. If you have registered for Math 12, Math 16A, Math 17A, or Math 21A for winter quarter, you're automatically registered to take the placement exam. If you have registered for the workload pre-calculus class or the workload Math D class, you will need to manually register to take the placement exam. And manually register means you fill out an online form and it like sends you an email with instructions for how to log in to take the test. You do not have to take the exam. if you have registered for the workload pre-calculus class or the workload math D class. You don't have to take the placement exam. My suggestion is always, if you've got the time, just take it. In terms of, if you happen to get the score you need to place into calculus, you don't have to take calculus. That score is held for 4 years. So like you won't, if you happen to pass it right now, you don't have to worry about it again. So my suggestion is always just take it. It's more practice with taking the exam. And if you happen to get the score you need, then cool. It'll be sitting there waiting for you when you're ready to take calculus. Yep. You could switch into calculus. My strong caution about going straight from here to calculus is both the 21 series and the 17 series have a lot of trigonometry in them. And we have done absolutely no trigonometry in this class. So if that's something that you maybe had already in high school, then, and you're feeling good about your trig, or you feel like if you just did some quick refresher, then if you get the score you need, you certainly could change your registration for winter and starting calculus. But if you have not done trigonometry, I really would do that workload pre-calculus class or math 12 first. And yeah, it's totally fine if you're planning to take one of those in the spring, not in the winter. If that's like the timeline you're on, that's totally fine. Math 12 is offered in the spring and the workload pre-calc class is also offered in the spring. So, yeah. Though my same advice would hold, you might as well take the placement exam and just to take it. And if you happen to get the score you need, you're not like forced to switch into calculus just because you got the score to qualify for it. No, it's logged in your Oasis file. Yeah. So, yep. Okay, well, with that, I hope your studying goes well this weekend. I have Zoom office hours from 2 to 3 today. Math drop-in tutoring over in Shields Library is open on Sunday. And then starting next week, so like Monday and Tuesday, I will be in the math drop-in area in the lower level of Shields Library from 9 to 11 in the morning, both Monday and Tuesday. So you're welcome to stop by and ask me questions about stuff. Have a lovely day. Good luck studying for all your finals.